Hey folks, Mr. Dell here. Hey, we are looking at a problem that has to do with looking at equations of lines and the graphs of those lines and doing some predictions and matching and some little knowledge around slope and y-intercept. So let's dive into this. This is something that is coming from CPM's Integrated Math 1, and this is section 2.1.3, number 30, 2-30. So it says, when Yoshi graphed the lines y equals 2x plus 3 and y equals 2x minus 2, she got the graph shown at the right. One of the lines at the right matches the equation y equals 2x plus 3, and the other matches y equals 2x minus 3. Which line matches which equation? Okay, so we're going to answer that question. So something to remember, that this idea of this equation, right? Each of these are two different equations. Well, those equations have solutions. So each of those equations have ordered pairs that are solutions, right? For example, if I had this equation y equals 2x plus 3, and I wanted to know a solution to that equation, I could say one of the solutions would be when x equals 0, y would equal 3, right? If I plug in a 0, y would equal 3. So one of the solutions is exactly that. So if I put in 3 into the y and 0 into the x, that becomes a true statement. 3 equals 3, right? So that's a solution, an ordered pair. X is 0, y is 3. So there's an infinite amount of ordered pairs to represent this equation. That's why we graph it. The graph represents those ordered pairs. So the other thing to know about an equation of a line is there's this form that we have seen this pattern over and over again, and the form is y equals mx plus b, where the equation, if it's in this form where you have your y and you have your x, right? Your y and your x are always part of the equation because that's where you get these ordered pairs, these answers to those equations. But the other two variables in there, this m and the b, represent certain aspects of my line, which represents the solutions. So the m is your slope or your rate, right? It's your rate if you're doing application of a linear function. And then your b is your y-intercept, or also known as your initial value. Again, if you're doing application of and linear functions. So if I look at my two equations now, this is where now I can match them up. I can see they both have the same slope, right? So the slope is the same. They both have a slope of 2, which is the change in y. Remember, slope is always written, so let me put it over here. That slope is always written the change of y over the change of x. It's always a change in the horizontal, which is the y, and a change in the x, which is the vertical. So if that slope is 2, if I look at my lines, I can see that here. If I go from here to here, this change in y is 2, the change in x is 2. So if I look at this line here, and if I go from that point to that point, again, the change in y is 2, the change in x is 1. So that matches what that slope is for each of those equations. So the difference in these equations is this part, the minus 2 and the plus 3. Well, what do those represent? Again, back here, that's representing the y-intercept, where it crosses the y-axis. So we could see that this one here, the plus 3, which we discovered here, that 0, 3 is the y-intercept. So that's the point for this equation. So I'm going to mark it here. This equation represents y is equal to 2x plus 3. Okay? And then therefore the other equation, if you notice, this minus 2, it crosses the axes at negative 2 down here. At negative 2 crosses the y-axis. So that equation is y is equal to 2x minus 2. All right. So we notice we've got parallel lines, right? Parallel lines because they have the same slope, and we have different y-intercepts. All right. So let's keep going. So Yoshi wants to add the line y equals 2x plus 1 to her graph. Predict where it would lie and sketch it on the graph to show its position. So again, we've talked through, we know that that slope is the same as the other two. It's the 2x, so it's parallel. And in this time, though, the y-intercept, it crosses through positive 1. So how do we graph that? Quickly, how do we show all the solutions to this equation? All the solutions would, first of all, we know it's going to cross at this at y equals 1, and then it has a slope of 2 over 1, right? It has the change in y and change of x. So the horizontal change is 2, the vertical change is 1, so there's another point up there. And there'll be another point up there. It has that pattern of 2 over 1, right? So if we predict where this is and graph it, it's looking like this. So it's right there, and I can throw some arrows on there to show that it just continues on. So that's my y equals 2x plus 1 equation. Last question here. Where would the line y equals negative 2x plus 1 lie? Justify your prediction and add the graph of the line to the graph. So I didn't actually write my prediction in part B because it said to predict where it would lie and sketch it on the graph. So in words, I would say it. So y, I'll do it here. I'll do that for that B. Y equals 2x plus 1. My prediction was that is parallel to the other two lines, but crosses the y-axis at positive 1. And we showed that on the graph. Here, if I'm going to predict this one, well, this one also, so y is equal to negative 2x plus 1, also crosses the y-axis at positive 1, but has a downhill slope because it's negative. So here's what that one looks like. So if I'm going to graph that one, it crosses here, but instead of, so its change of y is still 2 over 1, but it's a negative 2 over 1. So it's going to have a downhill. It's going to be going down 2 over 1, down 2 over 1, down 2 over 1. So it's got these steps this way. So if I connect my dots and show what that graph looks like, that's what y equals negative 2x plus 1 would look like. All right, there you go. Hope that